Hello. Today I am going to discuss about Faraday's first law and second law. We have already seen about the electrolysis, that is the what is electrolysis, some kinds of electrolysis, some examples of electrolysis. Now I am going to discuss about Faraday's first law, second law on electrolysis. So before going to the Faraday's first law or second law, first we have take some examples. Let's see, if here a Cu2 plus is present, then if it will take 2 electrons, then it will produces 1 copper.
It will produce. It will produce.
And hence here if we take 2 Cu2 plus, then here 4 electron is 2 Cu. Hence if we take any number of copper 2 plus, and here electron number of electrons will be 2 into Na, gives Na number of copper. Now here this Na number of copper 2 plus means 1 mole of copper 2 plus, because Na number of any species is 1 mole. Just like 12 number of any species is 1 dozen, here similarly Na number of any species is 1 mole, and hence this is here as number of electrons is 2 into Na, so it is 2 mole. So it is 2 moles of electron produce here Na number of copper, hence it is 1 mole. Now here 1 mole of copper 2 plus, it means that here 2 equivalent of copper 2 plus, I designated as EQ. I will discuss later how 1 mole of copper 2 plus is equivalent to 2 equivalent. This is 2 moles electrons means 2 Faradays of electrons. Here F is the Faraday. F means 1 mole electron, that is 1 Faraday is equivalent to 1 mole of electron, and here it is 1 mole of copper means 2 equivalent of copper. Now question is, why 1 mole of copper 2 plus means 2 equivalent of copper 2 plus, or 1 mole of copper means 2 equivalent of copper? Because in case of this reaction here Cu2 plus plus 2 electron to Cu, so here number of electron transfer is 2, and 1 mole is equal to number of electron transfer into 1 equivalent. That means here as number of electron transfer is 2, hence here 1 mole of copper 2 plus equivalent to 2 equivalent of copper 2 plus. Similarly here for copper, 1 mole of copper, here also to produce the copper from copper 2 plus, number of electron transfer is 2, hence 1 mole of copper is equivalent to 2 equivalent of copper. So in conclusion, here we can say that here we can say that as Cu2 plus 1 mole Cu2 plus, that is in a number of, plus 2 mole electron produce 1 mole copper. Hence here 2 equivalent of copper 2 plus 2 mole means 2 Faraday electrons give 2 equivalent of copper. So here from 2 Faradays of electron 2 equivalent of copper is produced, or 2 equivalent of copper 2 plus is reduced. Hence if we divide both sides by 2, then we give that 1 equivalent of copper 2 plus 2 by 2, that is 1 Faraday of electron equivalent to 1 equivalent of copper. Hence here 1 Faraday of electron produce 1 equivalent of 1 Faraday of electron produce 1 equivalent of copper. Okay, or also 1 Faraday of electron reduce 1 equivalent of copper 2 plus. So it will keep in mind that 1 Faraday of electron produce 1 equivalent of any substance. Okay, so here if we take an example that let in a container here a platinum electrode is there, and in this part also platinum electrode is here. Now here if the electrolyte is copper sulfate, that is copper 2 plus, copper sulfate means copper 2 plus. Hence if we then give an battery, it is the negative side, it is the positive side, then this copper 2 plus as it is a cation, hence it is moves to the negative electrode, and here it is reduced to copper. So here if we pass through the wire 1 Faraday of electricity, then it produce 1 Faraday produce 1 equivalent of copper. If we pass here from here or through this wire x Faraday of electricity, then it will produce x equivalent of copper. Okay, now one thing, 1 equivalent of copper is equal to atomic weight of copper divided by 2. These 2 comes from the number of electron transfer. It is number of electron transfer. As here number of electron transfer is 2, hence 1 equivalent of copper is equal to atomic weight divided by number of electron transfer. Okay. So if we pass 1 Faraday of electricity through the solution, then it will produce 1 equivalent of copper, that is atomic weight by 2 number of copper. And in case of silver nitrate, if here a silver nitrate is present, and here also a negative and a positive electrode present, it is a battery, it is connected through here, it is here. Now this silver nitrate can be ionized as Ag plus plus NO3 minus. Now this Ag plus take 1 electron to produce 1 silver. So in this case 1 equivalent of silver is equivalent to just atomic weight of silver, as here number of electron transfer is 1, that is Y1 means atomic weight of silver, that is 108 gram. Now, hence, if in a system there are okay. Now, also one thing, 1 Faraday is equivalent to 9650, that is 96,500 coulomb. This is represented by C. C is coulomb. Coulomb is unit of charge, just it measure number of positive or negative charges. Okay. So 1 Faraday is equivalent to this coulombs. Now, if we consider that through any substance, say copper 2 plus, with a copper 2 plus, there q coulomb of charge passed, that is q number of electron is passed. Then what is the amount of copper produced? Now here q is in coulomb, so 96,500 coulomb equivalent to 1 Faraday. Hence 1 coulomb equivalent to 1 by 96,500 Faraday. Hence q coulomb equivalent to q by 96,500 Faraday. So q coulomb is equivalent to this Faraday. Okay. So here, as q coulomb equivalent to q by 96,500 Faraday, and in case of copper 2 plus 2 electron is copper, so 1 mole copper 2 plus 2 mole electron is 1 mole copper. So 2 mole electron means 2 Faraday. Now here, as 2 Faraday produces 2 equivalent copper or 1 mole copper, and 1 mole copper's weight is atomic weight. Also 2 equivalent of copper means atomic weight also, or 2 equivalent copper. If this equivalent weight of copper is represented as E gram, then we can say that here 2 Faraday produces 2 into E gram of copper, and equivalent of weight of copper we have already said is equal to atomic weight divided by number of electron transfer, that is 2. So here as q coulomb of charges required, hence here q by this is equivalent to q by 96500 Faraday. It is equivalent to 2 into E by 2F into this. I will discuss. Here, so 2 Faraday produce 2 into equivalent weight, that is attogram of copper. Hence 1 Faraday produce, just it is a simple unitary method, 2 into E divided by these 2 gram of copper. Hence that q coulomb's charge is equal to q by 96,500 Faraday. Hence this Faraday produces, just here to consider, E into q by 96500 gram of copper. Here we can replace this 96,500 by 1 Faraday, and this is called W. So W is equal to E into Q by F, where W is the amount of substance produced at electrode, that is cathode. Here as copper is produced, so it is a gram of copper, it is always gram of copper is produced during electrolysis, and E is equivalent weight in gram of copper. As here copper is produced, so it is equivalent weight of copper. Q is coulombs of electricity passed through solution. And F is called Faraday. So from this part here, F has a fixed value 96,500 coulombs, so it is a constant here. So if we just replace this constant and is equal to sign by proportionality sign, then we may write from here that W is proportional to E into Q. This is actually Faraday's combined law. from here we can say that two things, that W proportional to Q and W proportional to E. It will give Faraday's first law and it will give Faraday's second law. So, statement of Faraday's first law is the amount of any substance produced at cathode or amount of any substance liberated at anode, because here if we take just an reverse reaction where the anode is copper, then also if here 1 Faraday of electricity passed, then here from anode only one equivalent of copper is dissolved as copper 2 plus. So here if we passed 1 Faraday of electricity through this wire, then if copper acts as anode, then 1 equivalent of copper will dissolve. So from first law we can say that the amount of any substance liberated on cathode or dissolves from anode is equivalent to charge or electricity passed through this solution, that is Q. It is the charge or electricity passed through this solution. And from Faraday's second law we can say that if the amount of species produced at cathode or amount of species dissolves from anode is equivalent to their equivalent weight, or it is also called chemical equivalent. Now from this first law we can say that as W proportional to Q, hence we can say W is equal to Z into Q, where Z is the proportionality constant and it is called electrochemical equivalence. Okay, so this is Faraday's first law. Here we can say that the amount of any species liberated on cathode or amount of any species dissolves from anode is equivalent to charge or electricity passed through the solution. Now from this second law we can also say that if we passed say a q coulomb of charge, okay, q coulomb of charge through a solution, then it will produce W1 gram of any substance at cathode. Then W1 is proportional to, if its equivalent weight is E1 and W2 proportional to E2, where it is another species whose equivalent weight is E2, and if we pass the same amount of current, then it will give the W2 gram product. Now from here as we can say that here W1 is equal to let's say Q1 charge is passed, then it is Q1 into E1 by F1, and from here we can say that W2 is equal to, here if Q2 amount of charge is passed, Q2 into E2 by, sorry, it is F, it is constant F, Okay, hence we can say that W1 by W2 is equal to Q1 into E1 by F. We have obtained this previously, that W proportional to Q into E by F, and it is Q2 into E2 by F. Okay, now if Q1 is equal to Q2, then we can cancel Q1 and Q2, and F is also cancelled. Then we can say that W1 by W2 is equal to E1 by E2. So from this we can say that if same amount of electricity is passed through two different solutions having equivalent weight of E1 and E2, and it will produce W1 gram and W2 gram of the respective samples, then their ratios are equivalent to their equivalent weights. This is also another term of Faraday's second law. So Faraday's second law, another term of Faraday's second law is, if same amount of charge is passed through solutions of two different electrolytes having equivalent weight of E1 and E2, and then their ratio of the amount of the electrolyzed product is equivalent to ratio of their equivalent weights. Okay. So here, from Faraday's, in summary, from Faraday's first law, we take that W proportional to Q, and from second law, W proportional to E, that is equivalent weight. If we combine these two laws, then it is Faraday's combined first and second law, which may be written as W proportional to Q into U into E. Now, if we replace this proportionality constant, then we may write this W is equal to Q into E by F, as proved earlier. Okay. So this is the combined form of Faraday's first law and second law, and let us consider some numerical problems also. And another one thing, so this, and another one thing is, if X Faraday of charge is passed through a solution, then it will give X into E gram of that substance. Okay. So based on this, we just solved some numerical problems. But before going to numerical problem, another thing is here, that the Q is equal to I into T, where Q is in coulomb, I is current of the current passed through the solution, it is in ampere and T in second. T is time required to pass I ampere of current through the solution to produce q coulomb charge. That is, here if say CO2 plus present, it is minus, it is plus, here a battery. Now here if by taking t second is the duration of the battery, t second during t second total I ampere of current is passed through this solution, then q, that is charge in the coulomb passed through this solution, is equal to I into t. Okay, so we may write that as W is equal to q into E by F, hence W is equal to I into T into E by F, where I in ampere, T is the time of the duration of the reaction, it is in second, and is equivalent weight of that substance, and equivalent weight is equal to atomic weight by number of electron transfer, or in case of molecule it is molecular weight by number of electron transfer. Okay, so based on this we solve some numerical problems. First problem is, in a electrolytic cell, lead sulfate is electrolyte. It is given, and here 0.05 Faraday of electricity is passed through this lead sulfate solution. Then question is, how many gram of lead sulfate to lead, it is the reaction, how many gram of lead will be produced at cathode. That is, here a lead sulfate solution is taken, here this is cathode, here from a battery, 0.05 Faraday of electricity is passed through this solution. Then question is, here how many grams of lead will produced here. Now lead sulfate is ionized as lead 2 plus SO4 2 minus. So here in cathode, that is this negative electrode, it is called cathode, and the positive electrode is called anode. Now in cathode, here lead 2 plus 2 electron gives lead. So here number of electron transfer is 2, hence equivalent weight of lead is 2. Lead is atomic weight of lead by 2. Now we know that 1 Faraday of electricity produce 1 equivalent weight of lead. So here, as per question, the amount of electricity passed is 0.05 Faraday. Hence 0.05 Faraday of electricity will produce the 0.05, just unitary method. 1 Faraday gives this, so 0.05 Faraday gives this into E gram of lead is equal to 0.05 into atomic weight of lead by number of electron transfer 2. This is the answer in gram. Also, this question can be asked just by reverse method. That is, from this cell, if we pass 0.05 Faraday of current, then how many quantities of lead sulfate will be reduced? Will be reduced or will be electrolyzed, because it is a electrolysis reaction, so here reduction reaction is also can be called as electrolysis reaction. Now similarly here, just like previous, 1 Faraday electricity can reduce 1 into equivalent weight of lead sulfate. So 0.05 Faraday of electricity can reduce 0.05 into E gram of lead sulfate. It is 0.05 into molecular weight of lead sulfate by number of electron transfer, that is 2. Here, as lead sulfate is a molecule, hence here molecular weight is required. Now molecular weight of lead sulfate is 303 grams, so it is equivalent to 0.05 into 303 by 2 gram. Means actually gram is in above side. It will give 151.5 gram of lead sulfate. So 0.05 Faraday will reduce the 151.5 gram of lead sulfate. This is the answer. You may note down this. Now this second question is for an electrolysis of aqueous NaCl. For this, if 10 milliampere current is passed through this aqueous solution, then how many time is required to produce 0.01 mole of hydrogen? Now first we have to consider the electrolysis reaction of NaCl in aqueous medium. Now in case of NaCl, in here NaCl and water both are present. This is cathode, this is anode by battery. So NaCl give Na plus and Cl minus, and water give H plus and OH minus. Now here first the water is in the form of water, so can be water. Now here or it can be written as minus form. Wait minus. Okay. Now here the actually as we have seen earlier that the mobility of H plus is greater than of Na plus, hence H plus will reduce here to give 2H plus 2E to H2 gas. So here 2 mole H plus 2 mole electron can produce 1 mole H2, right? Hence here 2 mole electrons means 2 Faraday's electrons. So 2 Faraday's electrons produce 1 mole H2. Now as 2 Faraday produce 1 mole H2. So 1 mole H2 can be produced from 2 Faraday's electrons. We may write this as here in question 0.01 mole of H2 is required. Hence 0.01 mole of H2 produce 0.01 into 2 from 2 Faradays of current. Now here the amount of current is 10 milliampere, but our required charge is this. Now question is, what is the time of the reaction to produce this 0.01 mole of hydrogen? So as to produce 0.01 mole of hydrogen, this amount of charge is required. Hence 0.01 into 2 Faraday is equal to I into T. Now here if I in ampere and T in second, then the charge must be in coulomb. Hence here as 1 Faraday is 96,500 coulombs, since we multiply this, and here C is coulomb. This total is in coulomb unit, is equal to I is in ampere, but by question I is equal to 10 milliampere and milliampere, but here I is in ampere, not in milliampere. So we have to require convert this milliampere to ampere. Hence it is 10 to the power minus 3 ampere. So here I is 10 into 10 to the power minus 3 ampere into T is in second, and question is what is the value of T. So here we can just solve that T is equal to 0.01 into 2 into 96500 divided by this 10. Okay, 10 into 10 to the power minus 3. This second. So here, from here we can say that this is 10 to the power minus 2 into 2 we may cancel out this, hence this is 2 into 965, that is second, this term is 1930 into 10 square second, that means 1930 second. This is the answer. So today we have learned that W proportional to Q, W proportional to E from first law, from Faraday's second law, where and in common form W proportional to E into Q, where W is equal to E into Q by F. Here this 1 by F is proportionality constant, where W in gram, E in gram, Q in coulomb, F is Faraday. Here W is amount of product is formed or amount of electrolyte is reduced in gram. Q is coulomb of charge or electricity passed through the solution. E is equivalent weight of the product. In case if W is amount of product, then E is amount of equivalent weight of product, and if W is amount of electrolyte reduced, then E is the equivalent weight of that electrolyte. And also here W is equal to E into I into T by F, where I is current passed in ampere and T is time of passing of current in ampere, in second. So okay, good night everyone, bye.